So the purpose of this video is to show you how to estimate the radius of curvature of a curve in the road. In other words, imagining that if that curve created a full circle, what would be the radius of that circle? So let's zoom into our area in Northern Virginia. And so here we're in Fairfax County, and north is approximately upward. So I'm just going to zoom in on some random curvy looking road that I see. So this looks like there's kind of a curve here. So here's what I'm going to do. I'm going to zoom in on this. Don't zoom in too far, because the idea is that if this curve made a full circle, we would still want to be able to see this full circle on the grid, because we're eventually going to find the radius of this thing. So I'm going to take a screenshot of this on this laptop that involves pressing the key function print screen. So on this laptop, print screen is below the end button. It might be in a different location on your computer, but I'm pressing function print screen. So a screenshot has been taken, and I've already opened Microsoft Paint here. So I'm going to paste this using Control V into Microsoft Paint. Okay, so that's nice. So what I'm going to do is I'm going to take this oval tool. Now, obviously we want the radius of a circle, not the radius of an oval, so it would not be a good idea to try to fit something like this into my circle. That would be bogus. So get rid of that. But we do want it to try to be a circle. So I'm going to make this a little bit bigger so that we can see the circle more easily. And kind of like this. Now, how can I tell if it's a perfect circle or not? If it's a perfect circle, when you look at the flatness of the pixels at the top of it, it's going to be about the same length in terms of the flattest pixels at the top as it will be on the side. So anyway, this actually is pretty much a perfect circle. However, it's not the perfect circle that we want, so we're going to get rid of it. So let's do this again, and we'll kind of start clicking down here. In other words, look for where this would go down vertically and that horizontally, and that'll kind of give an idea of about where we want to be. And this looks like it's about right. And let's see, we have this being maybe a little bit tighter, or a little bit more vertical than we want it to be. So I'm going to kind of move it down like that. And now the circle's not quite what we want. Let's see. So we're going to kind of try to get this as close to being about right as possible. And it's okay if your circles may be slightly too small, because if you're trying to figure out the radius of curvature, usually you want to underestimate the radius as opposed to overestimate it. If you're trying to, say, figure out how fast you can drive around a curve, you want to underestimate you want to underestimate the radius, because that'll give you a smaller maximum speed, so that would be kind of safer. So this is probably about right here. So we have this. So the question is, where is the center of this circle? So this is kind of our circle for this curve. So we're going to go right through the middle of, I'm going to do a more narrow line, right through the middle of the vertical part of our circle. So like this, and I'm going to move it over a little bit so it's going right through the middle, and then do the same thing horizontally. And where these two lines intersect is going to be the center of the circle. I could have actually done it on any opposite ends of the circle, but it's a lot easier to do it with the vertical and horizontal ends, because of the pixels, you can actually tell where you're trying to go. In other words, where the opposite side is. In other words, if you go from the middle of the most flat extent of this side to the middle of the most flat extent of this side through the pixels, then that actually is the opposite side of the circle. Great! So now we know where the center of our circle is. When you look at this picture, it's right there. It's kind of in this little clump of trees. Kind of imagine going out from this driveway in this little clump of trees. Let's see if we can find that on Google Earth. Aha, going out from this driveway into this little clump of trees right here, this is the center of our circle. So we take our tools and the ruler. I don't want it in feet, I want it in meters, so change the units to meters. There we go. And so out from this driveway toward about the center of this clump of trees. Whoops. Click here. So I clicked, I did not hold. I accidentally dragged it the first time. And let's just be safe and go to the innermost edge of that so that it works no matter which way you're going. And this gives a map length 148.48 meters, ground length 148.73 meters. So that ground length, that's going to be taking into account things like hills and stuff like that. So we actually want the smaller one, the direct route, because the idea is that this is an imaginary flat circle. So it's a radius of 148 meters. So that's what we have as our radius of curvature for this curve. And that is how you can estimate the radius of curvature of a curve on Google Earth.